Good morning, students. I am Dr.L.Jennathun Nisha, Assistant Professor of Mathematics, A.D.M College for Women, Nagapattinam. Today, we will have a discussion about correlations and its applications. Now, correlation is the very important topic and it will be used to a lot of places in statistics and mathematics. Dear students, first understand the definition of correlation. Correlation is a statistical tool that helps to measure and analyze the degree of relationship between two variables. That is, it deals with the association between two or more variables. Now, let us see the types of correlation. Here, there are two types, positive and negative correlations. First of all, I tell you the definition of correlation. Suppose we have variables x and y. In a positive correlations, variables change in the same direction. That is, as x is increasing, y is increasing, or as x is decreasing, y is decreasing. The examples are height and weight, profit and investment, yield and rainfall. In a negative correlations, variables change in the opposite directions. That is, as x is increasing, y is decreasing, or as x is decreasing, y is increasing. The examples are price and demand, speed and travel time, age and eye vision. Next, what are all the methods available to study about the correlations? Correlation can be classified using graphical method and algebraic method. For graphical method, we use scatter diagram. For algebraic method, we use Cauchy-Pearson coefficient of correlation. Next, we will discuss about a scatter diagram method. Suppose we have two sets of data, x and y. Plot x on x-axis and y on y-axis. If we get a straight line, that is moving from downward to upward, indicates that two variables are perfect positive correlations or strong positive correlations. Diagram 1 indicates that. In the same way, diagram 2 represents the weak positive correlation. Diagram 3 represents the strong negative correlations, and the fourth one is weak negative correlations, and the fifth one is moderate negative correlation. Finally, we observe the last diagram. We cannot come to a conclusion, then either it is positive or negative. This indicates that there is no relationship between the two variables. Next, we are going to see Cauchy-Pearson coefficient of correlation. Pearson R is the most common correlation coefficient. Cauchy-Pearson coefficient of correlation is denoted by the letter small r. The coefficient of correlations are measure the degree of linear relationship between two variables, say x and y. The formula is r equal to n into summation xy minus summation x into summation y divided by root of n into summation x square minus summation x the whole square into n into summation y square minus summation y the whole square. Here, n is the number of observation in pairs. Next, how will you get interpretation of correlation? The value of correlation coefficient r ranges from -1 to 1. If r equal to +1, then the correlation between the two variables is said to be perfect and positive. If r equal to -1, then the correlation between the two variables is said to be perfect and negative. If r equal to 0, then there exists no correlations between the variables. Now we see the problem for Cauchy-Pearson coefficient of correlations. The problem is, calculate the coefficient of correlations between x and y for the following data. X values are 2, 4, 6, 8, 9 and 10, and y values are 4, 6, 8, 10, 8 and 6. Now, let us see the solution for this problem. See the table format. just list out the x series in first column and y series in the second column. Then square the x values in the third column. In the same way, square the y values in the fourth column. Finally, we find the product x into y. It is in the last column. Now get it total. Here the number of observation n is 6. The x series total is summation x equal to 39 and the y series total is summation y equal to 42. Then summation x square equal to 301 and summation y square equal to 360 and the product summation xy equal to 292. N is the number of observations. Now apply the formula. Substitute all these values in the given formula. In R, that is R equal to 6 into 292 minus 39 into 42 divided by root of 6 into 301 minus 39 the whole square into root of 6 into 316 minus 42 the whole square. On simplifying, we get R becomes 0.98. Here the value of R is positive. So we have got a positive correlations between x and y. Next sections we will see the spheres and rank correlations. In the previous sections, we have seen how to calculate chord-Pearson coefficient of correlations. In these sections, we will see the Spearman's rank correlations. First of all, we see how it different from chord-Pearson coefficient of correlation. This coefficient of correlation is also known as rank correlations, is given by Charles Edward Spearman in the year 1904. Now understand the difference between chord-Pearson correlations and the rank correlation. First of all, we see the weakness in the chord-Pearson coefficient of correlations. Chord-Pearson assumed that there is a normal distribution in the population. That is one of the biggest assumptions. That is unable to find the correct solution. That's the psychologist Charles Edward Spearman founded a new method. That's more all is based on the qualitative data. Again, the assumption is here we just calculating the qualitative data. Qualitative data like, for example, the beauty of a woman, we cannot measure with the actual figure. We need to give a preference that is order. That's why we give a rank. So we give a rank. This is more beautiful. This is less beautiful. This is relatively less beautiful. So another thing we consider about a leadership quality. Leadership quality can be measured with comparison. First of all, we understand the meaning of this rank correlation. Spearman's rank correlations measures the degrees of similarity between two rankings and can be used to assess the significance of the relation between the ranks. The formula is rho equal to 1 minus 6 into summation d square divided by n into n square minus 1. Here n is the number of observations and d is the difference between the ranks. This is the formula for rank correlations when the ranks are given. Now see the one problem. The problem is two judges in a music competitions rank the 7 entries as follows. Here the x values are 2, 1, 4, 3, 5, 7, 6 and the y values are 1, 3, 2, 4, 5, 6, 7. So calculate rank correlation coefficients between x and y. Before going to see the solutions, we can follow the given steps. Step 1. Calculate the difference of ranks of x from the ranks of y and write it under the column headed by d. Step 2. Square the difference d and write it under the column headed by d square. Step 3. Apply the formula rho equal to 1 minus 6 into summation d square divided by n into n square minus 1. Now let us see the solution. With the help of these two data, Calculate the rank correlation between x and y. In this problem, ranks are given by x and y. Assume x values are R1 and y values are R2. Here, R1 and R2 are given in the problem. Next step is the difference between the R1 and R2, that is D, it is in the third column. After find D, the last step is just to square the difference, that is D square. Finally, the value of summation D square is 12. Now, apply the formula. Rho equal to 1 minus 6 into summation D square divided by n into n square minus 1. Here the values which is equal to 1 minus 6 into 12 divided by 7 into 7 square minus 1, which is equal to 1 minus 72 divided by 7 into 49 minus 1. Finally, the value of rho becomes 0.786. Here the value is positive. It means the correlation is high and also in positive terms. Now, we are going to see regression analysis. Regression is the very important concept. This is used in many of the statistical and economical problems because its usage is very wide. First, understand the definition of regression. So, regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of data. So, regression equation is also based on two variables just like correlations. Now, we will see the regression equations. Regression equations we can find out in two ways. One is actual mean method and the next is assumed mean method. What are the equation mean? One is x on y and the second one is y on x. If it is regression equation x on y, then the equation will be x minus x bar equal to r into sigma x divided by sigma y into y minus y bar. Here r is the correlation coefficient. Sigma x is the standard deviation of x. Sigma y is the standard deviation of y. Here r into sigma x divided by sigma y equal to summation xy divided by summation y square. Once if we understand the x and y, y on x is quite opposite. Regression equation of y on x is y minus y bar equal to r into sigma y by sigma x into x minus x bar. Here r into sigma y by sigma x equal to summation xy divided by summation x square. This is actual mean method. Now coming to the assumed mean method. So in this method, regression equation for y on x is y minus y bar equal to byx into x minus x bar, where byx equal to n into summation dx into dy minus summation dx into summation dy divided by n into summation dx square minus summation dx the whole square. Similarly, for the regression equation for x on y is x minus x bar equal to bxy into y minus y bar, where bxy is equal to n into summation dx into dy minus summation dx into summation dy divided by n into summation dy square minus summation dy the whole square. Here x bar is the arithmetic mean of x and y bar is the arithmetic mean of y. I hope understand the concept of correlations and regression analysis. Thank you for your listening. Thank you, students.